Hello, it's Mr. Avant, your science guy, and I'm here to introduce our science project for the week. We are going to be making a wind turbine, and a wind turbine is a giant fan. It looks like a giant fan. You see them out on in the countryside or out in the ocean. The wind pushes on the blades, and the blades turn a generator, and the generator creates electricity, which is very relevant to what happened with our rolling blackouts or blackouts last week. We had some blackouts in Texas as well. They discovered that they did not have enough energy to support all of the cold weather, the extreme cold weather they had in parts of the country where it's not normally that cold. And so the power grid was overstressed, and the wind turbines were frozen and they weren't producing energy. But it is a clean and safe renewable energy that can be used to supplement our power supply, and it's also friendly for the environment. So we're going to go over the materials we need for this project. Basically, we're going to be focusing on the propeller part of the design, and you're going to be making your own. So let's look at those parts next. Okay, here we are. This is what every student is going to be given for this project. You're going to have access to masking tape, a pair of scissors, since a lot of you do not have scissors, a pencil, a new pencil with a nice crisp eraser on the end, some hobby sticks, popsicle sticks. We're going to have different sizes of these. We'll give you up to 4 if you need them, depending on what you feel like doing with your design. A push pin, and a paper plate. Now, the first thing we're going to be doing on Monday is we're going to be looking at this sheet. This is, let me let it focus, propeller design sheet. So what you're going to do on here is, as you can see on the top there, and I'm going to talk about this in class, there are many different reasons for why propellers are shaped the way they're designed. A lot of them are shaped for working in water, creating force or thrust in water. Some are made to blow air to cool you off. Some are made for larger or longer blades. Some are made to help airplanes fly, propellers on planes. So there's a lot of different types of propellers that do different things. And then we have some fans that are like this with a lot of different blades on it. These would be like the little fans that you see in your computers and things like that. Whenever you want to cool something down while it runs, we usually use these types of blades. There's also all kinds of variations on this. There are some that are shaped like this. We call them vertical fans. And there's actually some wind turbines that are basically, you have your shaft here in the middle, and then these things come out of the middle and they catch the air and it spins. We also have a squirrel cage blower that's long and round like this. Squirrel cage blowers are also, you see those on air conditioners and things like that. So what you want to do with this worksheet is you want to think about your design. You're going to be given a checklist too to help you go through the thinking process or the engineering design process. This is what engineers do. They think about they try to learn about their subject. In this case, we're trying to make something that will be turned by the air or by wind. We want something that wind will catch and turn. So we're designing something that is turnable by the air. And then you want to think about, okay, how many blades does it have? What is the shape of the blade? Do I use 3 blades? Do I use 2? Do I use 4? Do I use 8? All these are possibilities. Well, on this sheet, this is kind of set up to the same scale as this pie plate. Now you're going to be cutting your blades out of the pie plate. So I want to think about how big this pie plate is. It goes from here in the center out to here. So that means our blades need to be this long. If you want to, you can measure. It's about as long as this popsicle stick, I can tell. So I'm going to use my popsicle stick as a guide, and I'm going to make a blade for a propeller that's going to be this long. I'm going to go ahead and stick with this type of traditional fan blade that you see on your fans, like in your house. So it has a shape like this, that. Now it doesn't have to be perfect, but what we're trying to do is create one template. A template is like a master copy of something you're going to do the same thing over and over again. So once I have that, then I'm going to cut it out. Almost there. Ooh. Now that I've gotten this blade cut out, let's go ahead and cut make our lines on this pie plate. I'm going to flatten it out a little bit, make it easier to draw on. And I'm going to put my blade on here, right? But the thing is I want to make sure that it works around the center. So I can tell already that I need to trim this some. So if my center is somewhere in here, I'm going to use this to help me find the center. Let's say the center is like this. And here is the center here. See how this will probably need to, I'm going to use this line up here to help me. So let me cut that extra off. And you're going to have to experiment and you're going to have to adjust it. Now that I cut that part off, I need to make my blade. Right now I can set it down and cut these out. And with a little bit of magic, when I'm done, perfect. All right, let me go ahead and wave a magic wand. Okay, bam. I've drawn out my pattern of my fan, and as you can see, it is not perfect. I decided to go ahead and make lots of blades, but of course, once you go all the way around, you're not going to be sure if they're going to be evenly spaced. You're just going to have to make your best guess and adjust afterwards. You can see I had to redraw a couple of them to make sure they fit. So let's go ahead and use some more magic again, and when I come back, this will be cut. There it is. Now look, this is not perfect. You can see the center of the wheel. Some of these blades are not at the same angle, but that's okay. You know, remember, this is an experiment. It's got to be a little loose. It's got to be a little fast. We're trying to see what works and what doesn't work. I'm really excited to see what you guys can come up with. Also, you'll notice that it's very flat, and I don't know if you've ever looked at a fan blade before. I'll show you one in class, but propeller blades are usually not straight this way. They have a profile to where they're turned in. So let's experiment real quick. Now the trick to all this is that we want to use the push pin to go through the center of your fan or your propeller setup, and then you push it into the eraser. And of course it spins really well, spinning really, really well. But the only problem is that when I blow on it, it's not spinning. So let's try that. First thing we can try is folding our propellers over the same way so that they bend up a little bit. Like you want to fold them, then fold them back. Make sure they're all folding the same way. You want to fold them at an angle. Okay, let me try doing it this way too. Alright, so let me put it back together. Where did my push pin go? Okay, well, I have bent my propellers at an angle, as you can see, and I can blow on it, but I don't get a lot of spinning. But if we do the final test, of which we'll do in class, is I'm going to put a fan on it. Got the fan on. There it goes. Put it this way so you can see. There we go. So the propellers are catching the wind, and it is turning it. It's not very efficient. It's not the best fan I've ever seen. There are several things we could do to improve it. One thing I see that could be a problem is where the push pin meets the eraser, could have a washer. A washer is a flat piece of something that fits in between that helps it spin better. Best. But it worked. And what we're going to do is we're going to make one of these on Monday. We're going to try. Then on Tuesday we're going to improve our design. So now let me talk about some other things for this project. Okay, now here comes the hard part with this project, because we need to put this on a piece of paper that will be able to hang up on the wall. So there's a couple of additional things we're going to do here. First of all, we could use this cup, and I want you guys to come up with ideas too. I tried to pin the propeller on the cup, and it did not spin very well because it kept rubbing against the cup. We call that friction. Anytime you have friction in a system or something rubs against something else, it'll ruin the efficiency. It takes more energy to turn it. So that's why we use a lot of oiled parts and stuff like that in engines. Well, in this case, we can't do that. We need to have, what I want to try to do is have a pencil go through this cup, and then we tape the cup to the paper so that the pencil sticks out and the propeller's out here, and then everything gets taped to a piece of paper so we can hang it up. So we can make a really nice wall project outside. Now, what we're going to do Monday, of course, is we're going to try to start this project. Tuesday, we're going to keep working on it. Wednesday, we want to wrap this up by doing a redesign and see if we can improve our design, make it more efficient. Whenever you're trying to make a good energy system, you're trying to make it as efficient as possible, meaning the most power you can, or the most energy you can get out of something without wasting energy. Most of our systems waste a lot of energy, and we simply try to reduce the amount of waste in the system. And we've talked about that before. Whenever you run a car engine, a lot of the energy, it goes into heat and noise, and a little bit of it goes in the movement of your car. A tremendous amount of energy is wasted whenever you run a car, but it gets us where we need to go, and every year we make it a little more efficient. So there's a couple of things we're going to do first. We're going to figure out, okay, how tall do I need to make a pencil in order for it to touch the paper and then come up out of the cup a little bit, the eraser to come out of the cup. So I'm going to measure, I'm going to say it's about right there, and then either Miss Barad or I will come around and we will cut your pencil down with a pair of snips like this. Boom, right? The other trick that Miss Barad may not have this access to this, but I am going to drill some of these cups on Monday so that some of them have holes big enough for a pencil to go through. Okay, and that doesn't have to be perfect. It doesn't have to be centered. It helps, but it doesn't have to be. And then, of course, the pencil goes through the hole, right? And then this is going to go on a piece of paper. I'm going to tape it on. Now, when you use your tape, come on, focus. There we go. We want to do a couple of things. Now, whenever you're using tape, it always helps if you pull a few pieces off first and stick them on the side of your table. So let's start doing that. I'm going to tear some pieces off here. One. Tear off 5 pieces, and then give it to someone sitting next to me so they can get their tape next. There's going to be no glue on this project. It's going to be tape things together. Okay, I've got 4 pieces. First thing I want to do is I'm going to tape the pencil to the cup on the inside. There's 1 piece here, there, wrap it, okay? Then I'm going to tape it outside so it doesn't bounce around so much. Stay still, I hope, okay? Now, I played around, talk about efficiency. I was talking about how to make it better. I tried to change where the center hole is because I think that was also messing my design up. So I'm going to pick this new spot out, put it in and see. Now you want to back it off so it's not too tight, be able to spin freely. And then I'm going to tape it on to the paper. You want to go all the way around to make sure this doesn't fall off. We got plenty of tape. Made sure of it. See, I've been taping the bottom to it. There you go. And that's what's going to go up on the wall. You're going to have to fill out a checklist. You're going to have to answer some questions. This is actually a test. This is an assessment, and we want you to do your best writing on this project too. This is going to be out for all to see out in the hallway. Do your best work. This is going to make everyone really proud at La Belle Air when we're done. Okay, so it's taped to the paper now. Let's take a look at it. Let me turn myself over. There we go. Yay, there it is, and it's taped. Okay, and it spins. Now let's test it out in the wind. Come on, wind. There it goes. Not bad. It is a propeller. Okay, guys, I need y'all to try to do this on Monday and Tuesday, and we finish up on Wednesday. Good luck.